Hello everyone, I am Jittuko Omkarsai alongside my teammate Jeevan Kumar Kurra. So it is our pleasure to present our group project for the mechanism sessional course. Our work focuses on the synthesis and simulation of a windscreen wiper mechanism, which we have designed to demonstrate both its functionality and other principles. So in this project, we selected question number 1 from tutorial sheet 5, which involves synthesizing and simulating the windscreen wiper mechanism as illustrated in tutorial sheet 2 and question 6. So our goal is to create a functional simulator that accurately represents the mechanics of the wiper without any quick written effect.
Okay. Thank you, Omkar, for that. Okay, let's take a closer look in this mechanism that we are simulating. And the vapor mechanism can be classified in four-bar mechanism, where 3 points O2, O4, and O6 are grounded, as we can see here, forming the grounded link. The link O2A acts as the crank, while AB serves as a coupler, and O4B functions as the output link. The motion of the wiper is directly dependent on the output motion. Okay, let's move it on. So as we see here, the horizontal distance between ground hinges O2 and B is 150 millimeters, while the vertical distance to O4 is 50 millimeters. The length of the wiper itself 200 millimeters. We precisely solved this question using graphical method in tutorial 2 previously, but today we will approach it in analytically.
So now to determine the area wiped by the wiper, we will find the locus of points P, Q, R and S as the crank O2A rotates about the origin O2. We will calculate the coordinates of these points. The angle that O2A makes with the horizontal will be denoted as Ti, while the angle between O4B and O4C is fixed at 10 degrees. Our main objective is to derive the angle K, which is crucial for locating PQ, R and S. So here we will denote the lengths as A, B, C, D and E. As you can see the triangle O4, O2A. So to find the angle of O4, O2A, it is pi minus Ti plus tan inverse 1 by 3. Now here to find the length of F, we will use the cosine rule on the triangle O4, O2A. Then we'll obtain F as root over c square plus d square minus 2cd cos gi. Then similarly we can obtain the angles as AO4B and AO4O2 as AI and DI. As we have already found out the angles AI DI, so here as you can see AB is a straight line, so you can find out EI by
Now I will walk through the MATLAB code we developed to simulate the wiper mechanism. Let's begin the brief demonstration of the simulation. Let's talk about the code, how we have represented. We initialize the workspace and they define the dimensions of the mechanism. Variables like crank, coupler, output link and the wiper length are specified here. We also define the range of crank angles and convert into the radians. Using this, we compute initial angles and distances using trigonometry relationships. Okay, in this section we had the pre-calculations type. The key geometry is calculated for each crank position. Angles such as AO4 O2 and angle BO4A and the output angle of the wiper are determined. Additionally, the endpoint coordinates of the wipers are calculated to their paths. This ensures we have all the data needed for the plotting. Okay, this animation and plotting section is the heart of the code. Like the mechanism is animated by iteratively updating the crank, coupler and the output link positions. Wiper arms are drawn dynamically, with the traces plotting to show the sweeping motion. We also calculate the viper's velocity and acceleration based on the angular changes and adding the realistic touch to the simulation. In final, the system resets to this initial position. Key points like O2, O4, O6 are labeled. Finally, the system resets to this initial position. Like key points like O2, O4, O6 are labeled, and the viper's motion is visualized effectively.
So this is the exported version of the MATLAB code on SolidWorks software. As you can see the windscreen wiper mechanism here. So in conclusion, our project successfully synthesizes and simulates the windscreen wiper mechanism, providing insights into its operation and the area it wipes.
We hope that our presentation has given you a clear understanding of our approach and findings. Thank you for your attention.
Thank you so much.